Well, we just broke 100.
All right, can everyone hear me?
Mm-hmm.
Is my mic sounding okay?
Yeah, you sound good.
Sure.
Katie, I just saw your question. Yes, this is being recorded, and we'll be distributing the recording to our registered members. I know that was supposed to be Leon as host saying that, but just covered for you. So yes, we will be sending out the video recording link to all of our registered guests. So thank you for that question.
Thanks for answering that for me, Chuck. All right, 2 minutes to go. We'll just wait for people to continue coming in. By the way, Chuck, can you hear me?
Yep, you're good. You've got a studio mic. You're professionally set up.
I am. I tried. Because I have an older laptop, so I know it's probably didn't catch up to my qualities in 2020.
Vidansh, yes, we will be distributing the recording on this.
Hey, Rod. Is Rod here?
Looks like it.
Yeah, I think he's listening. Would it be possible just to mute the Q&A for now, and then we'll open it once we're actually ready to do the Q&A? That way we can filter questions more easily.
This is all coming in through chat, Leon.
Yeah, but there's also the Q&A that's open. Yeah. What are the future working possibilities for a high school student for space exploration? That's a good question. We could answer that later.
For our audience, when we get to the audience Q&A, we're going to try and run it through the Q&A button rather than through the chat button. I know a lot of people are saying hello through chat right now, and that's wonderful. Good to see you all. But we're going to try and keep the questions organized because I'm guessing we're going to have a lot, and so we're going to try and manage the questions. So if you have something you want to ask us, please use the Q&A button at the bottom of your screen, button if possible.
All right, so it's 12:01. Let's wait an extra minute. More people are coming in. I'm excited for this. If you guys want to introduce yourselves in the chat, your name, and where are you actually watching this from. I think that's going to be very interesting. I know we have people from all over the world watching this, from Asia, Europe, Middle East. We have India, 9:30 p.m. in India, Switzerland, Indonesia, Timothy from India, New Jersey, Tyler from New Jersey. Nice. Jonathan, it's looking good. South Africa, Guatemala. We got Lebanon, Jad. We got India, Spain, New York. Wow. We got a nice audience here. Chicago, Illinois.
Hey, everyone.
It's honestly beautiful. Look at that audience.
If only we could see their faces.
Well, the tiles would be about the size of a postage stamp if we did that.
India.
Okay, I think in a minute we'll be ready to launch the video, the introduction video with Rod. I'm surprised to see such a big Indian viewership. It's pretty late there. It's 9:30 p.m. But we also picked a good timing for this.
Indians love space. Yeah, kind of looks like that.
Okay, I'm going to ask Rod to launch the introduction video. So here's what's going to happen for our viewers. We're going to be launching an introduction video. After that, I'm going to be just welcoming all of you, introducing our panelists. And after that, we're going to have a short presentation from Pavlo, the CEO and founder of Spacebit. And after that, we'll jump right into the core questions in this conference. And after that, we'll transition out with a Q&A from the audience. So by the middle of the conference, I'll be asking you to type any questions you have in the Q&A section. So try not to fill it up too much right now, just so we can filter and see your questions later on. Does that sound good?
The new age of lunar exploration begins. Commercial companies all over the world are aiming to reach the moon. Spacebit is among them, being the first UK mission to the moon. In 2021, Spacebit is sending the first walking rover to the moon aboard Astrobotic's Peregrine lander. It is a tech demo of a walking rover called Azagumo. During the mission, rover will walk and explore the moon, taking various measurements, take full HD video and LiDAR scan data, and sending it to the Earth via the Peregrine lander. The second mission will be in 2023. During this mission, we will test the wheeled rover. It will act as a mothership, carrying up to 4 Azagumo, protecting Azagumo from the lunar nights and relaying signals back to Earth. The next mission will be in 2026. It will be dedicated to exploration of lunar lava tubes. The swarm of Azagumo will go inside lava tubes. They will make detailed 3D scans of the lava tube cave. We will gather data about lava tube's network. So the robust connection to Earth will be established and data will be transferred to Earth.
All right, thank you, Rod, for playing that video. That was lovely. Everyone, welcome to this conference. For those of you who don't know me, my name is Leon. I'm the founder of Worldwide Engineering, and I'm honestly super excited to have you here today as part of this conference. You know, we organized this conference with one single goal: to spark a sense of curiosity in you about space exploration. You know, space exploration is the next frontier for human civilization. You know, it's built into our DNA, this need, this curiosity to go and seek what is out there, to know what's the next step for us. And for us humans, space is the next frontier. You know, every day we're hearing about new achievements that are being done in the space industry. SpaceX recently successfully launched astronauts on their reusable rocket. Uh, NASA just launched a new rover to the moon, to Mars, sorry, the Perseverance rover, with the goal of searching for life on the red planet. And now we have Spacebit that is planning to send the first walking rover to the moon in 2021. And I thought, what would be a better timing than to have panelists from Spacebit, come up on this conference and tell us about their mission and what they think the future of space exploration looks like for humanity. So I would love you to meet three of our panelists. Our first panelist is Pavlo, who is the founder and CEO of Spacebit. We
Hello.
then have hey Pavlo. Then we have Chuck, who is the Chief Business Development Officer at Spacebit. Hey Chuck. And finally Anna, who is the Head of Government and Partnership at Spacebit. So
Hi,
what I'm
everyone.
going to ask each of our panelists to introduce themselves, give us a brief background of themselves, and tell us a bit about what their day-to-day job and responsibility is at Spacebit. And maybe we can start with Pavlo.
Sure. Well, I'm a CEO, so I'm in charge of everything. In charge of the people, in charge of the processes. But obviously, it's very good to have people who are helping me with engineering, helping me with outreach, with business development. And that's why I believe any venture can be successful if you have right people in the team, you believe in something, and you go there together. So that's what we do here at Spacebit. We are united as a team.
Thank you, Pavlo. Chuck, would you like to give us a quick introduction?
Sure. My name is Chuck Lauer. I am based in Michigan in the U.S. I run the U.S. office here. I joined Spacebit about a year ago. I've known Pavlo for, I don't know, almost 10 years through the International Astronomical Federation and various space conferences where we would meet back when the world was different and we could actually go places and meet in person. But I joined Spacebit as a Chief Business Development Officer about a year ago to really pull together this global BD strategy and build both our technical collaborations and our business and sponsorships. I've been a space entrepreneur for close to 30 years, a serial entrepreneur in tech speak, and have been involved in launch vehicle programs, satellite projects, commercial space stations, ISS programs, consulted to NASA, Boeing, other major space companies. So I've been doing this a while, and one of the very first programs that I actually got involved in was actually a moon program back in the early 90s. Ultimately, that one was not able to be successful because it was too early from a launching standpoint. But I've been interested in doing things on the moon for a very, very long time, and I'm thrilled to be a part of the team.
Thank you, Chuck. And last but not least, we got Anna in the house.
Hey, hi everyone. I'm Anna Hazlitt. I'm usually based in Dubai, but at the minute I am in Europe. I actually spent many years living and working across Asia. So I noticed that we have a number of people from Southeast Asia with us today. So just want to mention that I did spend some good time in India, Singapore, Malaysia, Philippines, Indonesia, and loved every minute of it. So yeah, I mean, I'm here, I'm part of the team at Spacebit. I head up partnerships and government relations. And I guess the biggest message that I want to say to you today is you should be involved in the space economy. There is so much going on. There is a whole set of new challenges and opportunities waiting for you to be part of. And we would be thrilled to hear from you after this conference. Maybe you can come and support us on our mission to the moon. But really, this is the industry that you should be working in. And great for you to join us today.
Thank you, Anna. So here's the plan today. We are going to start first. We have Pavlo, who prepared a really interesting PowerPoint presentation, diving deep into the Spacebit mission. After that, the second part of the conference, we're going to be going through a series of detailed questions about Spacebit as well as space exploration. And finally, in the last third of the conference, we're going to be taking questions from you watching this conference. I'm going to be asking you halfway through the conference to ask your questions in the Q&A button. With that said, I think we are ready for Pavlo's PowerPoint presentation.
Yes, so we have a PowerPoint presentation that's usually very exciting. And so here you can see our rover. So our rover has legs instead of wheels, as you can see, and it's quite small. So it's really basically just a CubeSat-sized rovers that we have. And interestingly, that our mission is in 2021. So just over 1 year time, we actually will be flying to the moon and leading the research on the moon from the UK. So, but as you understand, we don't have our own launch vehicle, so we're planning to use the ULA Vulcan launch vehicle, and then we will be flying together with the Peregrine lander from Astrobotic. It's very exciting. We believe that the Peregrine is one of the most capable landers currently on the market, and that's why we have chosen and partnered with Astrobotic on this flight. And then obviously after we land with Astrobotic, we planning to walk on the moon. So it's kind of a very small step for the robot, but it's something new for the engineering world as well. So as you can see, we have a robot with 4 legs, and it's relatively small. The mass is less than 1.5 kilogram. So it's relatively easy on power. As you can see, it's around 4 watts solar power generated from the current setting. Well, we have some limitations in terms of the design, as you can understand, but we will be communicating with Earth using Wi-Fi link. So Wi-Fi to the lander, and then obviously the lander will send signal to the Earth. And we have a number of instruments such as a camera, scanner, using laser, and we also will be measuring temperature and radiation on the surface. So, and obviously, as you can imagine, previous robots, Curiosity, 900 kilograms, U2, 120 kilograms, our rover is just 1.5 kilograms. So it's really a tiny rovers that we're planning to send. And many people ask me why legs. So the main idea is to be able to go on a rugged terrain, so you can basically go in places where you can't use wheels. And also it's kind of good for the isolation from the lunar surface, which is really interesting. So I've been also asked where are we going, and we're going to Lacus Mortis. It's that place on the moon where you can see on this picture. And what else? So some secrets here. It's a first mission, but we're planning other missions as well. I will answer more in the Q&A part. But the next step, as you have seen from the video, is to launch a mothership. So it's a larger rover with the wheels. So you'll be able to travel a longer distances and then stop. And Asaguma will go and explore some interesting places of exploration. And as you know, one of our goals is to go and explore lava tubes. So we believe that with legs, it's much better to go there and explore them. And there are quite a few on the moon, and that's something that we're planning to do in the next missions. So just final 2 slides before I'm getting back to Leon and my team. So here's a picture of our model of our robot. It was tested in lava tubes here on Earth in Japan. So that's what we had. And that's actually me. In the lava tube in Japan with our robot. Well, yeah, that's all from me, and I would be glad to answer most of your questions, and maybe hopefully all of them. And yeah, back to Leon. Thank you.
So Pavlo, from your PowerPoint slide, it made me ask a few questions. Why exactly did you choose a four-legged rover? When, for example, we've sent many rovers to Mars, we have a few space missions. Why did you opt to go the different direction and go for a legged rover instead of going for a wheeled rover? And what are the benefits and the disadvantages of having legs instead of wheels?
Sure, it's a very good question. And first of all, I would like to thank my engineers because it's a huge engineering challenge to be developing this robot with four wheels. It's something that no one ever tried. And even though it was in our imagination, now we have to make it work. We have to create this robot, and that's what we're doing right now. So in terms of the legs, why it's interesting design and why we decided to use legs? Well, first of all, as I said previously, there are some places on the moon which are quite difficult. Some rock terrain, you have rocks, you have slopes, so you can't really use the conventional methods of locomotion. You can't really use wheels to go there and then come back if you want to come back. So in our case, to have legs, it's actually been able to go in some places where you can't go with the wheels. So you can go at the different slope, you can go and maybe go on the rocks. So it's different approach to the locomotion and different approach to the exploration as well. Obviously, in terms of the challenges, there are quite a few challenges. You're absolutely right. So the biggest challenge is the motors, because we have many motors inside of our legs, so we have to protect them. It's not just one or two motors in a wheel. We have more than that. And basically, we have to shield it from heat. We have to shield it from radiation. So it comes with a number of engineering challenges, but it's exciting. So we like it. We like challenges. Mm-hmm. And that's why kind of it's both practical point of view and studying something new and going to places that no one ever been able to go, trying a new technology as a mission demonstrator, and maybe, and I'm sure that we in the future will have robots with wheels, we'll have robots with legs as well. I mean, the same we having here on Earth, the same will apply to space. So that's why we're doing it. We want to be pioneers and we want to do it.
What about on the energy consumption side of things? Have you done some studies seeing if your legged rover consumes more energy than wheeled rover? Because on the moon, energy is scarce. You're using solar panels, sure, as I can see.
Well, it really depends how you look at it. So if you really want to go into the lava tube, and you want to go 5 meters or 10 meters or 20 meters into lava tube, and you have this slope where you go deep and you have some rocks, and you talk about the energy that is needed by the wheeled rover. So actually, it will be much more or almost impossible to get there with the wheeled rover. But if you have legs, obviously, yeah, I mean, in general terms, because you have more motors, the consumption will be more. So in terms of going long distances, it's not suited for going long distances. It's suited to go to difficult places, to hard places where you can't go with the wheels. And that's the reason why we created this rover. And as you know, in the future mission, we're also planning to have a robot with wheels. So we will be able to take our small robots with legs to different places of exploration, and then they can jump out and go and explore.
Okay, that's interesting. So what are some of the sensors that are built into your rovers?
Sure. Well, as you understand, it's quite small thing. So it's basically just like that. You can hold it in your hands. So it's a tiny rover. So we have some limitations in terms of what kind of sensors we can fit. And in our case, we've been able to fit quite a few. So we have a camera. Hopefully we'll be getting stereo images. That's something that we're working on at the moment. You have LiDAR laser technology, so you can do some measurement with that. Also, you have a temperature sensor on the legs and inside of the body. And then also you have a radiation sensor. So we might actually accommodate more sensors, but that's our minimum. That's something which will definitely fly. And at the moment, we're looking for new interesting ideas in terms of what kind of tiny sensors we can fly. And actually, it's an open call. If someone has an idea of what kind of sensor would be needed, why we should fly it, or maybe someone has the sensor developed already, we would definitely be glad to talk to that person.
Mm-hmm. Okay, so I have a question. I think this one could be for Chuck, actually. So why are you focused on lava tubes? What are lava tubes and what's interesting about them?
In the early days of the moon, the moon was formed by a major collision between the Earth and a Mars-sized planet in the very early days of the solar system, almost 4 billion years ago. That collision knocked off a significant fraction of the Earth, which then reformed into the moon. And in that collision, all the rock melted, everything was molten. So even though the moon does not have the same internal magma volcanic geology now that the Earth does, in the early days it did. The lava flows that were coming out from the molten core of the moon were creating lava tubes the same way that you see in Iceland, in Hawaii, in Japan, other places around the world. When the lava is flowing fast, it creates this tube. The difference is that in Earth's gravity, there tend to be small. If you really saw how small that lava tube was that Pavlo was crouching down in Japan, it was really, really small. In 1/6 gravity on the Earth, or sorry, 1/6 gravity on the moon, the theory is that these lava tubes could actually be quite large, potentially domes hundreds of meters in diameter. Nobody knows. It's pure theory right now. There's surface evidence of the tubes. There are skylights that you can see where a meteorite punched a hole through the crust. And you can actually look down and see inside. So there's surface evidence that they're there, but we really don't know exactly what's inside. That's the purpose of exploration. In answer to why, the lunar environment is probably one of the harshest places in the entire solar system that has a solid surface. Yeah, if you go to Jupiter or Saturn, yeah, it's a different story. But any place that a person could actually go, the lunar surface has the highest temperature swing, has high radiation. If you have a solar flare or a coronal mass ejection, the radiation from the sun would kill you in minutes. The temperature swings from minus 100 to more than plus 100 C. The lunar dust is both toxic and sharp and abrasive. All of these things make it for a very, very tough place for people to live. When you go down under the surface, the lunar soil provides a natural radiation shielding. The cave environment stabilizes the temperature. So if people are going to live on the moon in a permanent settlement, mining resources, doing research, you need to have places to live that are more user-friendly. If you're going to live on the surface, you have to build what amounts to a big igloo out of lunar soil in order to shield yourself from the radiation and the temperature differences. That benign environment exists naturally in cave systems, the scientists believe. Our goal is to provide firsthand data, provide ground truth on the moon about what it actually is, what are the radiation levels, what are the temperature levels, what are the surfaces inside, what are the volumes, and assess the suitability of these cave systems as potential places for humans to live in the future.
Mm-hmm. So from what you're saying, does Spacebit have any plans for future human settlements on the moon?
Pavlo, why don't you take that one? I mean, up to you. I'll answer if you don't want to. Okay, I'll go ahead.
Sorry, good.
In the modern theory of how you do space, robots and humans are a team. It's just like our team, like any company team, robotic systems and human systems are compatible. And we are focusing.
Hello?
You're on now, Pablo. We're focusing on providing the robotic systems that can support human settlement. NASA is going to the moon. with international partners under the Artemis program. The first human landing in 50 years is supposed to happen in 2024. The first woman on the moon ever in human history will be part of that mission. And over the next 5 to 10 years, there will be a series of Artemis missions and other international bringing people to the moon. Our robots will help that process. Our robots will help look for water ice in the South Pole and in the permanently dark places, look for minerals that can be used for industrial processes. So our focus is robotics, but our purpose is to help humans live on the moon as the second home of humanity.
Mm-hmm. And this question is can be answered by you, Chuck, or Pavlo, whoever would like to answer it. So, what is the biggest challenge you've encountered developing this mission of sending those rovers to the moon?
Go ahead, Pavlo.
Well, there are a few challenges. The first challenge is to believe in this one. So when you have this idea, you start thinking to yourself, like, is it possible? And then when you decided that it's possible, it has to be your decision. It has to be like my decision as a CEO. I said, I have to say, yes, it's possible. We are doing this. We're doing a rover with legs. So that's actually one of the most difficult kind of jumps from here to there, actually realizing that we're doing robot with legs. And then obviously the whole range of the engineering challenges, the whole range of the business processes that Chuck would be able to say as well. But the most important part is people, as I said. So if you have a right team, you solve all the problems. So we don't see it as a problem, we see it as a new challenge. And for us, everything is possible, and it's something that we will do, and we're doing already.
And just to add to that, Pavlo, I think what's really interesting about Spacebit is that our team is all over the world. So we have offices in the US, in the UK, Ukraine, Poland, Luxembourg, Japan, and soon the UAE. So really space from the time that I've been in, and it hasn't been as long as Chuck, but really space is an international team effort. It's not one nation, it's multiple nations and multiple teams pulling together.
Yeah, absolutely. So we're quite international, even though it's a UK mission to the moon, but we have people working in the UK, we have people working overseas and different nationalities. And that's what it takes to get to the moon.
Right. And the COVID challenge, we're trying.
Absolutely, yeah.
We have to deliver hardware in 9 months. And so people are scattered all over the place, but the hardware's got to come together. The hardware's got to be delivered to the launch site and launched to the moon. So the new world that we're living in now presents an extra set of difficulties on what was already a very challenging mission, but we're managing.
Mm-hmm. And I'm sure it also takes a lot of capital developing a mission like that. You know, building something from scratch, a new technology, bringing engineers together. So then my question is, how were you able to fund Spacebit? Is it funded by private investors? Is it public? Is it government? What is your main source of funding for that?
Sure. So Spacebit to date is privately funded. So it's based on a VC model. We have 4 key investors, including Pavlo, the founder and CEO. When we look to the future and other larger missions, we will look to raise further capital for those missions. I think what's really interesting at this point in the space industry is that it's no longer a game for the government or publicly funded businesses. We're really seeing an uptake in privately founded, privately invested space companies, which just means it just shows and demonstrates that the industry really is growing. And it really just shows that, entrepreneurs can come in, startups can come in, there's new channels and ways of funding these companies. And it's great. I mean, to give you an example, the recent stat is the total investment into the space economy was up by 61% from 2018 to 2019. So we're looking at roughly $6 billion that went into the industry last year. that figure is only growing. There's a growing interest from venture capital into this industry.
The other that is important to understand in this new model that Anna was talking about is that NASA is actually taking a leading role in nurturing this new private sector space economy and soon be the lunar economy or the cislunar economy. The missions that we're booking on are called CLPS, Commercial Lunar Payload Services. What NASA is doing is something that is not a traditional government space program. They're not buying rockets, they're not building landers, they are buying a service, and private sector companies are providing the service to NASA. NASA acts as the anchor customer, but buying the entire payload. In the case of Astrobotic, the manifested payloads, which are I think 11 or 12 individual research payloads on that lander that are operated by NASA, are about 80% of the total payload mass. So NASA's being the anchor tenant customer allows a commercial landing company in Pittsburgh, Pennsylvania, to build a brand new lander, to buy a rocket, and operate the entire mission totally privately. NASA is just a customer. The other 20% of commercial manifest is what we're on. And so there are several other commercial payloads that are booking along with us. There's a company from Japan that we have signed an agreement with called Daimon that actually has their own little robot. And part of our agreement when we learned about the other commercial payloads is that we have a kind of a robot buddies agreement. This is a hard thing to do. So if you have a buddy system and the two little robots can help each other, can take selfies of each other, because our robots don't have arms, so it's kind of hard to do the selfie. So the only way you can actually get your picture is by having your buddy robot take the picture of you and vice versa. So cooperating with other commercial companies within this commercial ecosystem that NASA has developed under the CLPS program is the fundamental enabler that makes all of this happen.
Thanks for adding to that, Chuck. So we're about more than halfway through the question phase. I got still a few questions here, really interesting questions about space exploration in general. And after that, we'll be moving into the Q&A. We already have 60 questions from people. So we'll be compiling the best questions and I'll be asking them to the team. So I have a question for Anna, and I think, Anna, you'd be the best person to answer that. On Instagram, on Worldwide Engineering, I often post content about space exploration. You know, it's a very trendy topic with NASA, SpaceX, all setting milestone. And you always see a certain pattern, a certain discord that starts happening inside the comment section. And people start debating over if it's worth it for humanity to actually invest time, money, resources in a human colony and outside of Earth. And the other side of the coin says, actually, we should take this money and invest it in Earth and in repairing the Earth instead of this. So then my question is, it seems like we are investing in space and this is something that's going to happen. But then what are the economic benefits that this is going to yield here on Earth for average people like us that are living here and that won't be living in Mars anytime soon?
Right. Well, it's a big existential question, but it's true. I mean, we get this a lot. You know, when talking to even friends and family and other business colleagues, that why are we going to space? Why aren't we fixing all the different problems and issues here on Earth? I guess the simple answer is the socio-economic impact that space has here on Earth is beyond imagination. You know, the technologies that have come out of space exploration, the new job creation, the new skills and training and learning that we get through science and applying these technologies in space and back on Earth are just continuously developing. So it's something that it doesn't mean to say that we neglect the issues here on Earth. It means that we need to do both. So whilst we're advancing space exploration, understanding our solar systems, we can apply what we learn back here on Earth in many, many ways. And to really give a recent example, I mean, we just have to look at the impact that space-enabled technologies and applications have had recently during our pandemic. Being able to communicate with one another, being able to use GPS and other navigation and satellite imagery has been a huge enabler for us to understand what the issues are, effects on our climate, biodiversity. These are all things that can be measured from space. So it's an interesting question. I think we need to challenge the spend and the investment into space, but I think we need to look also at the upside and understand that better from a global perspective.
Mm-hmm.
Let me add just briefly on that. There's more than just what Anna was talking about too. The long-term future is actually using the resources from the moon to develop new energy sources, specifically space-based solar power, to beam clean energy back to Earth, to create space habitats, to create raw materials supply chain. Jeff Bezos is the richest guy in the world. He has a space company called Blue Origin. The motto of Blue Origin is millions of people living and working in space. That's the vision of the next 20 to 30 years. What those people are doing is creating clean energy sources to improve the quality of life of what will be 9 or 10 billion people back here on the surface of the Earth. So over the next 20 to 30 years, the vision goes beyond science and data and GPS to actual physical benefit, clean energy, clean resources from the solar system, benefiting the people back here on Earth too.
I'm glad you jumped on this thread, Chuck, because I have a question for you now. So on a practical standpoint, you mentioned the moon is a very harsh place. Radiation, it's cold, it's hot. But on a more practical standpoint, what is the main challenge we're going to be facing as humans colonizing other planets? That could be the moon, that could be Mars. What do you think that is?
Well, everything starts with transportation. And that's why NASA and the other national space agencies and commercial companies are all focusing on the lunar South Pole being the first place to go. There has been physical evidence from orbiting missions in the past that there are water resources frozen into the craters on the South Pole. Permanently shadowed regions collect the volatiles and turn them into water ice. And millions of tons of water ice means you have rocket fuel. Water is hydrogen and oxygen, which is the best rocket fuel. Oxygen is needed for people living there. The resources of the South Pole can be the feedstock that allows humanity to expand out into the solar system, going all the way to Mars. And there are Mars architectures that are using the hydrogen and oxygen from the moon as the fuel to get there. So it becomes part of building an ecosystem and an industrial base that allows the cost of transportation to go down, which then enables more business cases to close and allows humanity to expand out into the solar system.
Absolutely, and beyond the solar system as well, Chuck. One day I'm sure that we will go to the stars. And obviously there are business questions, something that we believe is important for the businesses, and it will have a downstream effects and it will be used here on Earth. But also it's a worldview, it's ability to view beyond and see and do beyond our Earth. So, I mean, if you look at all the conflicts that we have here, all the problems we have here, in actually doing something beyond that, helps us not only from the business perspective, but also from the social perspective, so we can engage in something more meaningful in our lives. So I believe that's another reason, and that's why many people are doing and they're engaging in space exploration.
Mm-hmm. Thank you. And for my last question, and that's something I'm personally really curious about. We have some of the world's most influential people people like Elon Musk, people like Jeff Bezos that want to colonize space, but especially what's interesting is Jeff Bezos, who wants to industrialize space. He wants to um, go on the moon and, for example, collect natural resources from the moon that will then help us, advance society here on Earth. What is what mineral, if you want to call it, would be most interesting to collect from the moon? Like, what are the advantages of doing so?
Can I take that?
Sure, yeah, Jack,
Sure.
go on.
As I said, water is the gold of space. The first resource is water ice collected in permanently shadowed regions, processed and turned into liquid hydrogen and liquid oxygen that are used for multiple purposes. But if you look at the data from the Apollo missions, every valuable material, silicon, titanium, aluminum, iron, magnesium, all of the things that we use, rare earths, platinum group metals, what makes our laptops work, the rare earths in the chips in our laptops, all of that is. And if we are going to expand our civilization into near Earth space and beyond, we can't be taking everything up from the Earth. It costs tens of thousands a kilogram to get something off the surface of the Earth just because getting out of the gravity in the atmosphere. The moon is a place where we have everything we need and the gravity is less and there's no atmosphere. So it's a place that can be used as a transportation and resource hub for all of the industrial feedstock humanity lives on.
I'm glad you said water, because it's one of those things we take for granted here on Earth, because we see it everywhere.
Yeah, absolutely. Water will be one of the most valuable resources on the moon. So there are questions where we can find water, which form, and maybe people believe that the South Pole is the cradle of the water depositories on the moon. And basically, if you do find substantial amounts of accessible water on the moon, that would help with the future lunar settlement, that will help to advance further. It will help even to go to Mars, because as Chuck said, I mean, it's fuel, it's technical stuff, it's many other things, and it's oxygen that you extract from the water, and that's why finding water in accessible form on the moon is very important.
Awesome. So I think we were entering the last third of this conference. I got all my questions answered, and now we're pretty much ready to enter the Q&A phase. So during this, our last 30 minutes, Rod and Katrina from the Spacebit team have been compiling some of the best questions you've been asking in the Q&A section of this conference. And I have a few here that I'd like to answer.
Before we get to that, can I'd like to make the announcement. Can we get that slide up?
Yeah, of course. That's very true. So we got a nice announcement from Chuck.
Yeah. So we have this is a preview sneak peek announcement for Leon's viewers here. The official announcement is not coming up for a few months, but the first social media participatory event that Spacebit will be doing is spacebit.com/showusyourmoon. So in the lunar cycle, we will be operating over the 2 weeks of the lunar day from the crescent moon facing one direction through the full moon, through the crescent moon in the other direction. So that 2-week cycle when we can see the moon from where we live is unique to everybody anywhere and everywhere in the world. And so we want to do a photo and video contest, Show Us Your Moon, where you can upload your own images of where do you see it? How do you see it? What is beautiful about the lunar phase for you? Because just over a year from now, that lunar phase, 2 weeks from one crescent to the other, will be when we will be on the surface of the moon and be able to have pictures from the surface looking back at the Earth. So we will be announcing a contest with prizes every month. We will pick a set of winners, and then just before we launch, we will have a grand prize winner with a a really nice prize, which we're holding off on announcing for now. But if you, we're just past the full moon now. In my place, it just sits right out there. And we want everybody to pay attention to the moon cycles, look at those beautiful views, and send us your pics, send us your videos, and we will be having an area of our website where everybody can post up, and we'll have prizes for the contest winners. So I hope that those of you that are interested can participate, and we will be looking forward to seeing the pictures coming in a few weeks.
So to clarify, it's spacebit.com/show-us-your-moon. That's where you do it. That's where you join the contest. Perfect. So let's move to the Q&A. So we get a really good question from someone asking, are the rovers controlled by humans, or will they have autonomous capabilities?
Yeah, well, it's a good question. Obviously, in the future, definitely we want our robots to be autonomous, especially when we have more than one, we have swarm of robots. It will be difficult to control them from Earth, and because there is a delay and there are some. So during the first mission, it's more or less point and go situation with some possibility for autonomy if something's wrong, but mostly we will be basically guiding robots from here. We have our own control room in the UK where we will be basically doing it step by step almost approach, but then there is some level of autonomy which we might engage at the end of the mission to see what's going to happen. But we are optimistic about that, and obviously it's both of them are important. It's important for humans to be able to communicate with the robot and the space asset and being able to guide it on the moon, as well as autonomy is important, especially if we want to go further, we want to go to the Mars. Autonomy becomes even more important, as it won't be possible to guide the same way we guided on the moon.
Awesome. We have another question asking, what is the speed of the rover on the moon's surface?
Yeah, well, it's a good question. So it can be relatively fast. So it can go maybe like couple of meters in a minute, but on the purpose we will be slowing it down so our components stay cool and we don't experience any heating problems or dust issues. So we don't want to pick up too much dust at the beginning. So at the beginning we're going to do it step by step, so really moving slow. We're talking centimeters per minute rather than meters per minute. So that's our initial approach, but we'll see how it goes. And obviously there are capabilities embedded in our system which allow us to go much faster, but that's not necessarily that we're planning to do it during our first mission.
Yeah, Formula One on the moon is a little bit later.
So while you're here, Pablo, we have a question from Francesco Crook asking, he specifically asked that question for you. So he asked to Pavlo, what advice could you give to all those who want to maybe found a startup in a field that they're very passionate about, but not necessarily connected to from an academic point of view?
Well, it's a good question. So first of all, I encourage you to be brave, not to think too much, not to reflect too much. Obviously, there's always reflection in the head of the founder. So you wake up, you go to bed, you always think about your startup, you always think about what you're planning to do. But the most important step is just doing something. Is if you want to start a company, start the company. If you want to do something, go in and do it. And obviously, there will be some hesitations. There will be some kind of thoughts in your head if it's the right thing. And there are a few ways around it. You can wait for someone else to do it. You can ask for advice, and maybe they will tell you it's a good idea. Maybe they'll tell you it's a crazy idea. You can expect both answers. But if you truly believe in something, my advice is just do it, and then find the right people who would understand you and who would be on board with you, and you will develop this. So don't be afraid to innovate. That's the biggest advice. And just do something and start it today, wait for tomorrow. But there will be many challenges, and obviously starting is just the first step, and you will doubt yourself many times. That's what I do as well. I mean, it happens every month. We all have doubts. That's normal.
Yeah, and you need to build your team. I mean, nobody can do anything like this on their own. You have to have a core team. So it's better to have a few founders that can join up with you, and it's much more comfortable that way, and it works better too.
Chuck, while you're here, I think there's a question you'll be able to answer from Jisbam Sanchez. What do you hope to accomplish or discover using this rover on the moon?
The primary science data from the first mission is characterizing the lunar dust particle environment. The laser scanner is actually a dust measurement device because the dust is what kills the mechanical systems. It's very sharp and abrasive, gets into mechanisms. And so what our laser scanner is doing is measuring the charged particle dust density at the lunar surface where things will be operating. We will also be doing laser communications tests back to the Earth, where we actually will be flashing a laser back at the Earth and seeing if we can acquire the signals. And we will be doing the temperature and radiation measurements because that relates to the habitability aspects of it. The temperature can swing 200 degrees between sun and shadow, and how quickly that temperature changes is something that we can do by having a temperature probe in each feet and being able to measure 1 foot in the shadow, 1 foot in the sun, and actually see what those temperature differences are on the lunar surface. So that is our science objectives on the first mission. The subsequent missions will have progressively more ambitious scientific goals, heavier scientific payloads, and ultimately we want to be prospecting for that water ice, get the direct surface evidence of the water, where it is, what's it like, how deep is it, and really build the database for resource development on the moon.
I think there's a question by Dinesh JD that will complement what the points you just brought up. What is the lifespan of the rover?
Pavlo, you go ahead on that one. It's your money.
Well, yeah, absolutely. So there is a energy lifespan, basically in terms of how long we can function without sun. So if you go to the lava tube with a normal temperature, when I say normal temperature, it's something between -20 to +20. And that would be in a number of hours. Because we're on the surface and we have something like +75, +80 degrees, up to +90 maybe in some hottest parts of our trip, then we will be constantly getting a few watts from the solar panels, so we'll be charging ourselves. And because we are not constantly moving, we will be able to live for longer. And obviously, what would be the ultimate limit for our current design is the lunar night. That's something that we won't be able to go through. And as we are landing a couple of Earth days into the lunar day, we would estimate our lifespan of around 8 to 10 days, like Earth days. So basically, we're going to land at the beginning of the lunar day, and we will live till the lunar night. And as shadow basically comes to our rover, everything starts to deteriorate quite fast, and temperature drops fast on the moon. So after that, we won't be able to sustain the communication, and then the batteries would die, and then it probably will be it for our rover.
Till we come back.
So, question from Julian. After the mission, will the rover be abandoned on the moon?
Well, we don't want to think about abandon. I mean, if you think about the Apollo missions, they also left certain things behind, but that's a heritage. That's not abandoning something, but that's leaving something. And that's a different meaning. So we leave something for the future generation. We leave something to be explored in the future. We tell us science, tell us a story, which is super important for our civilization. If you look at some places on Earth, if you look at the pyramids, if you look at some other historical monuments, some of them are actually abandoned, or as you can say it, but we don't see them as abandoned. We see them as a message from the past, as a message from the history. That's why for our robot, it will play its part in the history of the UK, history of the space station, and then it will stay there as a monument of something that we have achieved on the moon, and it will help for the future missions, and maybe it will tell science for the people or robots who will find it on the moon one day.
So question for Anna from Delta J. Does Spacebit collaborate with ESA or other private space companies? If so, where are these companies from?
Sure. So just to go back to the original point here, Spacebit is the UK's first mission to the moon. So this is the principle of the company. It's a UK founded, UK based company, and it is the first mission to the moon next year. It's also the first mission to send a walking rover to the lunar surface. So right now we have a collaboration agreement with JAXA, which is the Japanese Space Agency. And we are working towards other agreements and other partnerships with other national space agencies. But I can't say anything other than that for now, because we're about to announce this. But stay tuned, and you'll hear a lot more of the types of partnerships that we're working with.
We also have a partner in the U.S. with the University of Michigan Engineering College of Aerospace. The Michigan Exploration Lab is one of our technical team members that are avionics and flight hardware for the missions, and we'll be having our first test articles rolling out of the lab within a few months here. So we'll be starting our terrestrial test program in the October timeframe, and we'll be testing through the end of the year and then delivering the flight hardware in the spring of 2021. So we have academic collaborations as well, and we're certainly open for other academic collaborations globally for instruments, science, and data analysis too.
Absolutely, and I would like to share an email. So I'm just sharing one slide, and you can see here, so we're looking for technical, scientific, and commercial partnerships. And you can write us at info@spacebit.com. So if you believe that you have something to share, or you want to collaborate on the technical aspects, or maybe you're interested in science, and we will be doing a lot of cool and interesting science on the moon. So it doesn't really matter from where you're coming from, just contact us and we will make sure that we help you to collaborate with us. So info@spacebit.com. Thank you.
Pavlo, I'm glad you brought this PowerPoint slide up, because 10% of all the questions we got on the Q&A were the same. They were, how to apply for a job at Spacebit? Do you have a certain link or a certain place where people can put their CVs in?
Well, Leon, it's I have another slide for that. So we are well prepared. So in terms of the job openings, we have a different email address. So you can write us at hr@spacebit.com, and we're definitely hiring. We're hiring engineers, and we're hiring for some other roles. So if you believe that you have something for our mission and you want to really help us, or you just want to engage in space exploration, just shoot us an email and we see what we can do. And we have some live openings on LinkedIn as well as on our website. But hey, we don't want to limit you with a specific job role. So if you have something in mind, just shoot us a message and we'll try to answer it. Thank you.
We also have a student brand ambassador program too. So if you are still in college and it's going to be a few years before you're entering the job market, there are still some things that can be done. And so we have this brand ambassador program for students as well.
I hope everyone took a screenshot of the previous slide.
We'll share the information after.
Okay, and we have two final questions. One is kind of a general question from Jigan Srinivasan. And the last one is a CEO level question specifically for Pavlo and about the future long term of Spacebit. That's a question by Nusrat Ali. So the first question by Jigan is, why are nations rushing to colonize in space by leaving the most suitable place for humans, that is Earth?
Let me take that
question.
It's a good question.
You could always
I
say
mean,
something.
I can answer it. I mean,
Okay.
if you don't even have to answer it, if you, and you know, probably know who Tsiolkovsky is. Tsiolkovsky said one day that Earth is a cradle for civilization, but it doesn't mean that we have to live in the cradle forever. So I believe that it's a spirit of many human beings to be explorers, to go and explore, to find something new. That's how we found different continents. That's how we moved. That's how we engage in trade and international trade, and how we met different people. I mean, at the moment, our travel is a little bit on hold, but I'm sure that it will be back online soon. But that the same thing applies to the space exploration. So that spirit of explorer and going beyond and finding something new applies not only to Earth, but also to space. And I believe that in the future, with new technologies, we will be able to go beyond the solar system and be able to live on other planets. So that's just a thing. We started here on Earth. It's very important to care about Earth, to care about Cradle, not to do harm to it. So we always come back to our roots, which is super important. But then, hey, we generally, as a species, I believe we should become interplanetary and we should aim for the stars. Absolutely.
There's a Robert Heinlein quote as well. The Earth is much too small and fragile a basket for humanity to keep all its eggs in. And that's actually the largest driver for Elon Musk. His focus on Mars is about a second place for humanity. And so it's not one or the other, it's both. And doing this benefits both and benefits humanity as a civilization.
Cool. And one final question, and that is for the CEO. And it's from Nusrat Ali, and it's a pretty existential question. Are you ready for that, Pavlo?
Yes.
So what is the end goal of Spacebit? Where do you see yourself in 10, 20, and 50 years from now?
Sure. I mean, in terms of space exploration, it's very difficult to talk about the end goal. Probably there is no end goal, so we kind of explore, it doesn't end. And obviously business, if you want to develop not only space business, but any business, it should change, should adapt to new environments. So now it's a moon, in the future we'll go to Mars. In terms of 10 years time, I strongly believe that we will have some permanent presence on the moon as a company and as a human species. So the United States goes there and they don't go there alone, they go there with international partners. And we will be playing an active role in a robotic exploration of the lunar surface. And that's our goal for the next 10 years, and supporting functions for the human exploration. So discovery function, being able to see and send the missions in front of the human missions, and then to support human presence on the moon. That's the role for our company for the next 10 years. And then obviously going beyond that, maybe we're talking about Mars, maybe also talking about expanding the presence on the moon. Maybe there'll be some other developments. It all depends on what we find on the moon, if we have water on the moon. So the first is exploration. Second one is being able to settle. The third one is actually produce some natural resources and go on. And obviously, as a business, at every single level, we have to find what is the business incentive, and that's what we're doing right now. So you have to stay profitable. It's not like a conventional business. We really require substantial capital to be basically acquired so we can do it, and that's why we have to be profitable at every single
I think we're losing you, Pavlo.
Oh, no, there he is.
Yeah.
He's back. Okay. The I I would suggest part of the answer to that question is actually to go. There's a book by Professor Gerard O'Neill. It's called The High Frontier. It was originally written in the 1970s, but it talks about exactly this. What is the next 50 years? What is the future of humanity in space? That O'Neill vision is where the millions of people living and working in space from Jeff Bezos comes from. And so for your viewers to go and find a copy of The High Frontier by Gerard O'Neill and read that would give a really good answer to that long-term 20-year to 50-year vision of where humanity could go.
Awesome. Thank you, Chuck. Thank you, Pavlo. Thank you, Anna. This was beautiful. I just want to invite all of you, if you have any closing announcement, any closing remarks. I know Anna wanted to talk to just share a snippet of something. Do you have anything to say before we part ways?
Yeah, I think so. Pablo mentioned earlier that we are looking for various types of different partnerships, whether it's scientific, technical, commercial. Also interested in brand partnerships. So if anyone out there works for a brand, works in a creative agency, advertising, marketing, we'd be really keen to speak to you because we're looking at bringing brands along this journey with us to the moon. So if your brand wants to be on the moon, then definitely contact us.
And also, we would like to thank Worldwide Engineering. We'd like to thank you, Leon, for hosting us here. It's a great pleasure to be featured on your program. And hopefully we answered most of the questions, but if not, just send us email to info@spacebit.com and we will try to answer your questions. I'm sorry, we have a limited format here. And thank you, Leon.
Yeah, not even close, Pavlo. There's 159 questions in the Q&A stack right now. So we've got more questions than we have people on the call right now. We'll try and respond. If we can capture all of that before we pull the plug on this webinar, we'll try and capture that and see if we can post up a sort of a consolidated answer set offline over the next few days when we release the recorded version of this.
Yeah, so just so everyone knows that's currently watching this, we're going to be releasing a rewatch for this conference. If you want to share with your friends, if you want to take more notes, if you want to rewatch certain parts, you're going to be receiving an email from me with a link to the rewatch. It's either going to be on YouTube or it's going to be on podcast, so you can listen to it. And yeah, we'll take it from there. Pavlo, Chuck, Anna, Rod, Katrina, thank you so much for making this happen. It was honestly great having you here. And honestly, we're all glad to be part of the future with you guys.
Absolutely. Thank you very much. Thank you, everyone. I would like to thank the audience as well. Yes, absolutely.
Thank you.
Bye-bye.
Bye.
Thank you. It's beautiful.